This is the first video of Chapter 1 Introduction to Thermodynamics. What is thermodynamics? Thermodynamics. This word comes from the Greek roots thermo, meaning heat, and dynamics, meaning power. So thermodynamics was originally developed to study how heat can be converted to power or mechanical work. Usually, this conversion from heat to work is made possible with the help of some working substances. For example, in an internal combustion engine, a series of processes happen in working substances, which may be the mixture of fuel and air, or some combustion products. And because of this series of processes inside these working substances, heat comes from the combustion of fossil fuel can be converted to mechanical work. Internal combustion engine, in fact, is one example of so-called heat engines. A heat engine is a machine that converts heat, that is thermal energy, from available sources such as combustion of fossil fuel to work, that is mechanical energy. Other examples of heat engines include vapor power plants, gas power plants, and rocket engines. In fact, human societies are literally powered by such heat engines, since about 80% of energy utilized by human beings comes this way. However, thermodynamics is not limited to heat engines. In fact, thermodynamics studies the transformation of energy. So as long as a process or a phenomenon involves energy transformation, it can be studied by thermodynamics. Since almost every process and phenomenon we observe in nature and in our daily life involves energy transformation, they all can be studied by thermodynamics. Some examples include the refrigeration systems. For example, the refrigerators and air conditioning systems. Such systems involve energy transformation, so they can be studied with thermodynamics. Another example is air compressor, which also involves energy transformation, so it is also a good example of thermodynamics. Once we finish this course, you will be able to understand why and how such engineering systems work, and you will be able to do critical engineering calculations, and you will be prepared to rise to problems with new solutions. One challenge we face in this age is the so-called energy crisis. This crisis exists because we are running out of fossil fuel, which must be replaced with other energy resources. With the help of thermodynamics, we can come up with new solutions to meet this crisis. Some new ideas include the compressed air car and high-efficiency engines. All such systems can be studied and understood with the help of thermodynamics. Thermodynamics is not only very useful, it is also very interesting. For example, here we can see a very simple structured device, which is nothing more than a hollowed chamber with one inlet and two outlets. At the end of one outlet, there is a small cone-shaped part. Although this device has such a simple structure, it can do something very significant. That is, if we feed this structure with compressed air at room temperature, the device is able to split this air into two streams, one stream really cold and another stream really hot. This device is the so-called vortex tube. And how can vortex tube do this? We will be able to understand this phenomenon after we finish this course. Another interesting phenomenon that also can be explained with thermodynamics is shown here. When we stretch a metal wire, its temperature is going to decrease. However, if we stretch a rubber band, its temperature is going to increase. Isn't this interesting? And we will be able to explain why this happened after finishing this course.